All right, good morning, everyone. Today we are interpreting the whisker plot. So yesterday we talked about how to make box and whisker plots, but today we're just going to be talking about if one has already been made, then how do we interpret that information? So if we look at this box plot here, just a reminder, this is the minimum, Q1, median, Q3, and the maximum. So a quarter of all the data are in between each piece. So here, this is a quarter of the data, and one way to write a quarter, oh no, hold on, is 25%. So this right here is 25% of the data, like we talked about before. From here to here is 25, from here to here is 25, so this entire thing here must be 50%. And then from here to here is another 25, or another quarter of the data, so this is 25%. Okay, so it just means that when you look at a box and whisker plot, you don't know how many data points you're talking about. What you do know is that 25% of them are here, 50% of them are here, 25% of them are here. Okay, and another measure of the variation of data is the interquartile range, which we'll just denote as IQR, which is the difference of the third quartile and the first quartile. So the IQR is equal to Q3 minus Q1. And so that is doing Q3 minus Q1. So that's just telling you where the middle 50% of the data is, where most of that data is. Well, I guess not really most, but where half of the data is, okay? And it's important to know where that middle half is because that's where a lot of those points are going to be. So let's look at a couple of examples. All right, so let's look at the type of questions that you might be asked. So, A, find and interpret the range of the data. So we know the range as high minus low. So we can look at this and say, what is our high and what is our low? So our high is 300 and our low is 160. So I'm going to do A up here, maybe. Yep. Okay. A. So A is going to, I guess I can get rid of this doodle here. So A is going to be 300 minus 160, which we know is equal to 140. So then it says to interpret the range of this. And so what this means is since we are talking about the lengths of the songs played at a concert, that means that the songs varied no more than 140 seconds. So from the high minus the low, the difference has to be 140 or less. Okay, so interpreting the range, what we just talked about, is that the length of the songs varied by no more than 140 seconds. So just meaning that those songs are like any song over here must be within 140 seconds of any song that is on the lower end. Okay, so B is to describe the distribution of the data. So this question is just asking you, okay, when you're looking at this data, how can we interpret it? And you're going to interpret it using kind of the whiskers here and the information that these are quartiles. So we're going to say that 25% of the data, or 25% of songs are between 160 seconds and 220 seconds. And 50% of songs are between 220 seconds and 280 seconds. And 25% of songs are between 280 seconds and 300 seconds. So I just paused it to write that down. but 25% of songs between 160 seconds and 220 seconds, 50% of songs between 220 and 280 seconds, 25% of songs between 280 seconds and 300 seconds. That's what we're looking for when I ask you to describe the distribution of the data for right now. All right, C, find and interpret the interquartile range of the data. So we could remember that the interquartile range of the data is the IQR, which is Q3 minus Q1. So if we look here, Q3 is 280 and Q1 is 220. So we would have 280 minus 220, and that is going to give us 60. And what that means is that the middle 50% of the songs, or the middle half of the songs, aren't going to vary any more than 60 seconds. So all these songs in here, the higher ones minus the lower ones, like they're within 60 seconds of each other. In a similar way that I wrote this one here. So here, when we were interpreting the range, the length of the songs vary by no more than 140 seconds. So this one here, the middle 50% of songs vary no more than 60 seconds. So basically, when you're dealing with a range, you are making comparisons about the high minus the low. And so you're thinking about, is the range or the high minus low between any two songs going to be more or less than some number? Okay, D, are the data more spread out below Q1 or above Q3? So if we look at below Q1, so here's Q1, and from Q1, we're talking about 220 to 160. And above Q3, we're talking about 280 to 300. So you can tell just by the length of this whisker that the data is more spread out below Q1. My right here is that it's more spread out below Q1 because the left whisker is longer than the right whisker. So because the left one is longer than the right one, this is more spread out. If you wanted to, you could do 220 minus 160 and see that 80 is bigger than 300 minus 280, which is 20. So you could use numbers if you want to, or you can just say which whisker is longer than the other one. All right, we just have one more example problem, and then you can stop listening to my voice. So the next type is comparing box and whisker plots, where they're double box and whisker plots or triple, where you're just looking at more than one set of data being compared to each other. So here, this double box and whisker plot represents the test scores for your class and your friend's class. So your class is this blue one, and your, and your friend's class is this red one. So before we're able to do A, which says to identify the shape of each distribution, what we are going to need to talk about is the way that we define shapes of distribution. So there's three types. There is when it is skewed left. When the shape is skewed left, that means that the left whisker is longer than the right whisker. And what's going to happen is that most of the data are on the right side of the plot. So we look here. Remember, this is 50% or 25% of the data, 25%, 25%. So most of this data is on the right-hand side. That is called skewed left. Symmetric is when the whiskers are about the same length. Doesn't have to be perfect, but they're about the same length. And we see that the median is exactly in the middle of that plot because it's symmetric on both sides. And then we have skewed right. So the right whisker here is longer than the left. So here's this right whisker, it's longer, which means that most of the data is on the left-hand side. So we look here, and most of this data is on the left-hand side, because this is 25%, 25%, 25%. So here, A said to identify the shape of each distribution. So if we look at your class's data has this longer whisker on the left-hand side. So this one is going to be skewed left. And your friend's class seems to be more symmetric because the whiskers are about the same length and median is in the middle. So your class is skewed left, your friend's class is symmetric. B, which test scores are more spread out? Explain. So when we're talking about more spread out, it means that there is more variation, that you have a wider range. So if we look at these two things, your friend's class has a low of 60 and a high of 100, whereas your class seems to have a low of 68 maybe to 100. So your friend's class is definitely more spread out. So B, your friends' test scores are more spread out because the range is greater. Okay, so today we talked about looking at a box and whisker plot and identifying what the range is and interpreting what that means. That just means how much the data varies. We talked about the interquartile range, which is Q3 minus Q1, and interpreting that. And that's just going to tell us where the middle 50% is. And then we talked about comparing two types of box and whisker plots. So being able to look at two things that are being compared against each other. And we also talked about the shape of a distribution. Skewed left means we have a really long left whisker here. Symmetric, they're about the same. Skewed right would be if I had a box and whisker plot that had a really large whisker on the right. All right, make sure that you check Google Docs so you can see what practice assignment I have for you today. If you have any questions, please email me.